Assalamualaikum and hi everyone. Today we want to present about our topic which is volumetric analysis, determination of salt in food sample using titration. First of all, we want to introduce to our group members which are Naadhiroh Binti, MH Mohammed Sharif, Nurin Amanina Binti Zuraidi, Faika Auni Binti Hasamuddin, Amalin Safiah Binti Md Radzi, and Nur Anisha Binti Anuar.
First of all is introduction to volumetric analysis. Volumetric analysis also referred as titration. It is a quantitative analytical method that involves preparation, storage, and measurement of volume of chemicals for analysis. This method is widely used in chemistry for precise and accurate measurement. This method is used to determine unknown concentration of known reactant. Substance with known concentration placed in a burette will react with substance of unknown concentration in conical flask. Next, definition of term. Titrant. A titrant is a solution of known concentration that is gradually added to another solution of unknown concentration. Titrant usually in burette. Endpoint. Endpoint is the point at which the reaction between the titrant and the analyte is complete, typically indicated by physical change such as color change or pH change. Analyte. Analyte is the substance or chemical component in sample that being analyzed in laboratory tests. Analyte is the solution of unknown concentration that react with the titrant. Purpose of the analysis is to determine the concentration of the analyte in the sample. pH indicator. pH indicator is chemical compound that change color depending on the pH level of the solution. pH indicator are used in titration to visually signal the acidity or basicity of a solution. Example of pH indicator is phenolphthalein. Equivalent point. The equivalent point in titration is the exact point at which the quantity of titrant is added to the analyte based on the stoichiometry of the reaction. Aims to determine and often detect the endpoint.
Next, we continue for the introduction of volumetric analysis. So the basic principle of volumetric analysis is based on the reaction between a titrant and an analyte. The solution which we want to analyze contain a chemical of unknown amount. Then the reagent react with that chemical of unknown amount in the presence of indicator to show the endpoint. There are several apparatus that needed for titration, which are pipette, conical flask, wash bottle, burette funnel, and lastly volumetric flask. Titration involves three processes, which is preparation, setup apparatus, and titration. For preparation, two solutions are used, which is solution of unknown concentration and solution of known concentration, which is standard solution. We must make sure all glassware to be used must clean with distilled water. Pipette and burette will be rinsed with the solution used. Then, to set up apparatus for titration, we must fill the burette with one of the solution and attach to a clamp stand above a conical flask. There is a suitable indicator added to the conical flask. Pipette is used to measure an accurate volume of the other solution and transfer into the conical flask. The diagram on the right shows how the titration was set up. Finally is titration process. First thing first, we must record the initial reading of the solution in the burette. To begin transferring burette liquid into the flask, turn on the stopcock and at the same time, continuously swirl the flask. As soon as the indicator starts to change color, we must slow the solution flow. When the indicator color changes permanently, intake for at least 30 seconds, immediately stop the flow and then record the final volume. We must repeat the titration step until at least two consistent values are obtained.
First is acid-base titration. Determination of the concentration of an acid or base by neutralizing the acid or base with an acid or base at known concentration. It involves neutralization reaction which is an acid reacted with an equivalent amount of base. Equivalent point is number moles of acid equals to number mole of base. For example, is titration between NaOH and HCl. Second is redox titration. It involves oxidation and reduction reaction between the titrant and the analyte. Example is redox titration between MnO4- and Ferrum2+. Third is precipitation titration, based on reaction that yield ionic compound of limited solubility. Precipitating agents are used due to the slow rate of formation of the precipitates. Example, precipitation titration between CuSO4 and NaOH. Number 4 is complexometric titration. Reaction between metal ion and suitable ligand to form a complex compound. The equivalent point is determined by an indicator. Example, complexometric titration, water hardness.
Theory behind the Moore method. Firstly, argentometric titration. This technique is based on the precipitation reaction between silver ion and chloride ion. Next, indicator. Potassium chromate is chosen because it forms a color complex like silver chromate only after all chloride ion have been precipitated, making it a suitable indicator for the endpoint. Lastly, stoichiometry. The method relies on the 1:1 molar ratio of silver to chloride ions, allowing for straightforward calculation of the salt concentration based on the volume of titrate used. Benefits of determination of salt in food sample using titration: preservation, flavor enhancement, texture improvement, color retention, nutrient preservation.
For the last part, I will explain about experiment to determine amount of salt in food sample using titration. The apparatus that we use are analytical balance, burette, 250 ml conical flask, blender, redox stand, white tie, 50 ml measuring cylinder, dropper, wagging board or wagging dish. Chemical reagents that we use are 5% potassium chromate as indicator and 0.1 mol silver nitrate solution. Next, there are some procedures to do this experiment. First of all, some homogeneous portion of sample was took into a blender cup. The sample was blended into powder. If we use butter or ghee sample, apply heat first to turn the sample into liquid. 3.5 to 5 grams of blended sample was weighed and the weight was recorded. The sample was transferred into a clean and dry conical flask. 50 ml of distilled water was added into the conical flask and the solution was swirled to mix the content. The content was mixed for 30 minutes with occasional swirling. 1 ml of 5% potassium chromate solution was added into the flask. Swirl the flask to mix the content properly. After that, 0.1 mol silver nitrate solution was added into burette at a redox stand and the initial burette reading was recorded. White tie was placed under the conical flask. The titration was started by adding drop by drop 0.1 mol silver nitrate into the conical flask while swirl it. The titration was stopped when the color of solution in conical flask changed from pale yellow to reddish brown. The final burette reading was recorded. The result is the solution in conical flask before the titration is pale yellow color, but after the titration, pale yellow color turned to the reddish brown color. The last part is calculation for this experiment. Examples of result is sample of weight in gram 3.5028 gram, volume of silver nitrate used in milliliter, final reading minus initial reading 22.8 minus 17.8 equal to 5 ml. Concentration of silver nitrate is 0.1 mol. The formula used to calculate the percent of salt in food sample is volume of silver nitrate used multiply concentration of silver nitrate and relative molecular mass per molarity of the sample of the salt divided by the weight of sample. The percent of salt in this experiment is 0.83%. Sample that we use is a slice of cake. Okay, there are some reference we get from internet based on this experiment.
In conclusion, determining the salt content in canned food is essential for ensuring food safety, maintaining nutritional quality, and complying with regulatory standards. Accurate assessment methods such as titration, spectroscopy, and modern sensor technologies provide valuable data for manufacturers and consumers. Regular monitoring helps prevent health risks associated with high sodium intake, such as hypertension and cardiovascular disease. Ultimately, consistent and precise measurement of salt level in canned food contributes to better public health outcomes and informed dietary choice.